Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen.
Voor iedereen?
Even wachten Jan,
Ja.
dat is nog niet klaar. Ik ben Ronald Kers en dat was natuurlijk...
Jan Stomphorst, Solutions Architect, ACC ICT.
Hoi Jan,
Hallo Ronald.
Devult dag 2.
Zo, nou echt, we hadden het al over de spelletjes, we hadden het al over dingen. Het is ook echt een hele mooie ruimte dit. Een hoop mensen tegengekomen. Heel leuk.
Heel leuk inderdaad, ja. En ik raad ook echt iedereen aan om volgend jaar gewoon ook weer naar Devult te komen, want het is echt een heel leuk event.
Ja, en nu gaan we het over Java hebben.
Ja, dat wil jij heel graag hè?
Ja.
Ja. Aflevering na aflevering heb jij het over heap sizes and everything. So I would like to introduce Usama Nasir.
Yep.
Okay, welcome.
Thank you. Thank you for having me here.
A pleasure. And can you please introduce yourself to our listeners?
Yeah, sure. So I'm Usama, originally from Pakistan, currently based in Berlin. And outside of tech, I love to follow football, something that we all love in this region especially, and also like movies. And apart from that, I also like to stay, up to date with all the stuff that's going on in the tech world, which is why I'm here in dev world as well. And professionally, I'm currently working as a staff engineer at GetYourGuide. And GetYourGuide is like a platform that provides unforgettable experiences to all the travelers around the world. And the product, by the way, aligns well with what I love. I also love to travel, so it's also exciting to be in the domain that looks after solving challenges in the travel domain. So
Right.
So yeah, that's pretty much the short introduction of myself.
Yeah, and how did you get started in the IT? What sparked your interest?
So it's funny that I don't, let's say, have like a fancy story to share that since childhood I was doing DOS or Pascal or this or that. And it's funny when I was trying to choose careers back then in Pakistan, the fields that were highly in demands were electronics, electrical engineering and stuff like that. But during that time, the whole IT, the time that I'm talking about is mostly 2007, 2009. Back then, IT was gearing up in Pakistan. A lot of new opportunities were coming in. So based on that, my parents felt that maybe this is the right field to choose, and that's how I ended up there. But yeah, once I was there, I started studying a couple of courses, especially the course that was close to my heart still, which was object-oriented programming. Felt it really nice, how solving by using several design patterns or techniques that are out in this languages, how you can solve customer problems basically. So from there I picked up the interest, and yeah, so far it's been going good.
Okay, great. And you had a talk here, garbage collection in
Yes.
modern Java application, GC considerations for microservices.
Yeah.
It's a long title, but can you tell?
Wait. Before
sorry.
we start,
Yeah.
we're going to talk about Java memory. But before you start about garbage collection, I want to know Java memory. How does it work and how is it set up? Because our listeners don't know everything about Java memory.
Yeah.
And
Garbage collection.
Got it.
and garbage
I guess
collection.
first we go with how the memory
Okay.
works,
Yeah.
and from there we
From there, because
how does it clean.
Because if you don't know how Java memory works, you can tell a lot about cleaning.
Exactly.
But that, yeah.
Exactly. So what goes behind the scenes, when we are coding, we are initializing a lot of variables. Hey, x is equal to 1, s is equal to hello world. And what happens behind the scenes that the computer assigning memory in the heap, placing all these objects there, and then basically making sure that as long as the code is getting executed, it's using these things from those places. It's basically storing some sort of reference, like a pointer. So imagine if I want to know what x means, I have a pointer now to basically go back to see, okay, yes, x is basically this, and that's how the program basically knows, okay, that x was 1 and s was hello world. This was very high level, so that everyone can understand that what is going on when we are initializing variables. There's some sort of placement going on in the memory, and then what happens once the code has gone through that path, obviously the new code has to execute. The new code also will be initializing variables. Those also need space. So we need to have some sort of a process that ensures that, okay, if X and hello world is no longer needed, let's now go and remove those as the code has already gone through that path and now has moved to something where new variables need some sort of space. So very high level so that the audience from different backgrounds can understand what goes behind the scenes.
So, but in Java, you've got something like not like a normal program. You've got like something like in heap space, a predefined space,
Yes.
which uses Java, does this magic in. Why does Java have a heap space?
I guess like the major thing is like this heap space is some part of your main memory as well, right? Which makes it like very easily accessible and like very quickly you can move around things and have those objects retrieved. And the reason like why it's like already allocated, so like it's already like efficient in a way that I understand that it's not like dynamic, but already like initializing like an address block that in the memory, like this is the space that we will utilize, already makes it easy, the life for Java. Let's say, okay, that this is the memory that I work with, and if now the program needs more, and I cannot handle it, so already do not overcommit. That's I guess what Java tries to do. So I cannot overcommit other than what you already have for me. So like other than the space that's allocated, if you go beyond, then we see things like, any developer's worst nightmare, which is like out of memory errors.
OM, out of memory killer.
OOM.
Out of memory. yeah.
That's
comes along.
but you don't have in Java. Not only you have a heap space, but you've got Eden space. You've got all the other spaces.
Yeah, it's just too much like JVM. It's too complicated when we go to that depth, and which is why like interestingly, like for my talk as well, like when I was thinking up to which extent do I want to go, and like these things were also like in my mind. Okay, do I really want to go to that level, or whether the audience would understand that, or I should just take like a step back and stay like high level, like whatever is really relevant to them. But yeah, like once you go inside the JVM, like there are so many things going behind the scenes which are let's say really tricky. And even what I believe, like no matter how much you read about that topic upfront, but until you don't face like the infamous OMs and issues like that, you won't dive deep into those things to figure out what's going on, basically.
Okay, but why do we have then? Java has a heap, and we've got an Eden space. It's outside the heap, and we've got other spaces. Why do we have more spaces outside of the heap than inside of the heap? I think that's stupid or weird.
I guess like this is like one way for Java to optimize this whole memory management thing. Okay, that the heap is more for objects that are still live, that are still being used by the application. And then you have some sort of allocations basically for the objects that you feel that are still not live and can be later on removed or stuff like that. So I guess this is just like an efficient manner that, okay, fine, you have different spaces for different sort of work. So if something live going on, if you need something for longer stays, then I guess maybe that's where we can utilize heap. It's very like quick to fetch those details. But then for certain things where you don't really need that sort of a quick retrieval, then obviously those things can be moved from heap, because like you mentioned, like there's a specific sort of space that's available. So you cannot like put everything in one place. You need to have some other buckets as well where you can move things around so that the program can still work, and provide the expected results.
Isn't it the same as like storage? The philosophy, you have fast storage for the things that you're actually using, and if it's like not used anymore of that often, it's falls back to the slow storage.
Yeah.
No, something like that, yeah.
Exactly, like that's how I feel about it. Like it's just like have several buckets like that Java has, and it's based on what sort of thing is executing. If it's really needed, for fast retrievals, it's placed in one place. If it's like like the same concept that we have with hot storage or cold storage, like something that's needed very frequently, it's placed in hot storage, but something that's just needed once in a blue moon, you can move it to cold storage, basically.
Okay, and then we've got that heap and we've got that memory, but you said we're making objects in that memory, and then something has to remove those old objects.
And that's where the talk comes in.
Yeah. It's my.
Now we have the context.
Now you have the context. Yes.
Go, Ronald.
What I said.
That was a good way to put it. Awesome. Awesome.
So that's where garbage collection comes in. When garbage collection removes those objects and then cleans the older objects, because Java is not as a C program, it doesn't remove its objects in real time.
Yes. So exactly, like it's funny, like in my presentation, like when I was trying to explain exactly what it is, I just like showed like them like a picture of Undertaker, standing up all of a sudden and picking up those objects, disposing them off. So it's exactly like that, that you need to have some sort of process going on so that it shows that, that the memory that's claimed by those objects, that's like reclaimed and can be provided to the other objects that's needed. And then the talk is, goes more into that. What I feel is like when we developed multiple services in GetYourGuide, I felt that we sort of overlooked the whole idea about, how the garbage collector works. And we felt that since microservices are small, they just do one thing at a time. They will not be like crazy big. They will not have requirements of, let's say big heaps and all that stuff, which I guess led to us, overlooking the whole thing. And then ultimately, led us to situations where we had to spend our weekends figuring out why OOM is showing up, and then from there investigate and find the root cause. So the talk was just mainly focusing on that garbage collection is still relevant, even though it's microservices, even though we have Kubernetes, so you can scale horizontally, but does not mean that garbage collector is now something that you can ignore altogether.
No, you said you've got 4 kinds of garbage collection.
Yeah.
What are those 4 kinds?
So the first one, the simplest one, the easiest one, like serial garbage collector, does one thing at a time. So if there are like garbage collection events that needs to take place, it will just process one and then move to another. It's like one threaded. You can say it's good for, let's say, your testing development environments or maybe very small applications, but not at all something that you should think of using in production environments. And then the limitations that we had with this one was removed through the parallel garbage collector and provide like multiple threads, and now like multiple garbage collection processes are executing in parallel. Obviously, like drawbacks is considered as also like stop the world kind of a garbage collector.
So he's and the second one is doing garbage collection, and during the garbage collection, it's not doing his program.
Exactly. So it means that if it's doing garbage collection, it says, okay, now everything has to wait.
Yeah.
Let me clean this mess, and then you begin your work.
It's just like a toilet, toilet mist, and it closes the door. I'm cleaning toilets, and then opens and up again. Wait, you can't be.
but still, like it's what I guess what audience needs to understand also that does not mean that this is something that you cannot use altogether. Like there are maybe applications where it's totally fine to have such pause time. Maybe it's just like a background process, like a job or something that's doing some heavy processing, some uploading of big data. So in those cases, it's fine. It's like there's no customer that's getting impacted just because everything is happening behind the scenes. So it's like in those cases, it's good to it's like you can use this garbage collector. So it's not like even though it says stop the world does not mean that this is something that you can.
Well, it's stopping the work for milliseconds. So we're talking really fast.
Yes, exactly. It's not
and
like
it's faster than the first one.
Oh, definitely.
Because it's doing nothing and it's cleaning.
Yes, and then it has multiple processes to execute, right? Like it's not just like one thing, one process who's doing everything basically. And then we go, and then is the next one is like G1GC or G first basically, and this one like brought like the balanced approach. Okay, that it's not basically bringing a lot of pause times, but also providing support for these applications that need large memory, and which is why at some point Java also decided, I guess after Java 9, they decided to make this the default one, because they felt, okay, this is the right sort of balance that may work for across majority of the applications. So people don't need to, let's say, worry much about, okay, what garbage collector they are using, and the default one, let's say, works for the majority of the use cases. But then there's another one, ZGC, but like you have applications which really needs, very high responsiveness, very low latencies. And in those cases, even though like G1GC says that they are, let's say, very frequent pauses, but in those cases where like huge sort of traffic coming in, those few pauses also can, sort of create like a snowball effect and ultimately leave you in a place where you see OMs. And I guess that's where ZGC comes in and provides you, let's say, a sort of balance that, okay, fine, I will work with a huge heap size. And based on the incoming traffic, I can adjust dynamically according to the needs. I can say,
Oh, that's cool.
Yes, that's the cool part about it. So imagine now there's a huge traffic coming in.
Mm-hmm.
So ZGC, just because it has a huge heap size, it looks at the heap and it says, yeah, but there's a lot of space, right? So let's not pause the stuff. Let's serve it, and then I can follow up after once things sort down or settle down. And I guess that's one of the best thing about this, that in G1GC still you had to do some sort of tweaking here and there in order to get the optimal results. But this one, like, it automatically decides based on the traffic, based on how the heap is going on, and then decides what to do. But like the talk was also mentioning that there's no one size fits all, so it's not like, maybe the audience might be also thinking that maybe ZGC is the go-to thing. But if it was, then why it's not default, right? Like that's something that you could already think, that if ZGC is the next big thing, then
if it's constantly busy, then when are you going to garbage collect then?
Exactly, and that's where the problem comes in. That imagine you have a scenario where you're not doing garbage collection, right? Even at that moment, let's say the traffic was fine, so you decided, okay, let's let the program continue, but you're still keeping those objects into the heap. It means that they have occupied the space, and now all of a sudden there's a huge spike of traffic coming in. Mm-hmm. And now, since the ZGC decides, okay, that the heap is already high, now I need to also run this garbage collection process. But the problem is that now the ZGC will start with a higher baseline just because it has not removed those objects. So in this particular scenario, and there's something like, it's funny that this exact same problem is what we faced in one of our services. And the root cause was nothing but just basically this, that ZGC was actually not doing the garbage collection just because it thought there's no traffic, but the object size were high, so it already had occupied some space in heap. And then when the traffic came in, it started to do this pauses basically just to remove quickly the things. But then by the time, there were requests coming in, and those pauses led to, again, server accumulating those requests and then reaching to the point where it says, okay, fine, bye-bye. Let's start from the beginning. So yeah, I guess the main idea was to basically explain the audience that let's not overlook this, and also just don't say that there's one size fits all. Look at how your service behaves internally, right? Like if your service behaves in a way that there's like a similar pattern of traffic coming in and it's always high traffic, like you already receive a lot of large volume, then fine, go with ZGC because it will provide you the optimal results in this case. But if we're just talking about sometimes, some inconsistent volume of traffic, and sometimes it's high, sometimes it's low, then the G1GC would work fine in this case, just because it will not leave those objects there for larger time, and you also don't have the requirement of large traffic coming in all the time. So it will provide you optimal results in this case. So it was funny that in my talk I first started with ZGC, how ZGC solved the problem. And the next service I said, but we had to roll back ZGC in other service just because it did not work well.
And if I'm a DevOps guy, is a garbage collection something I could help the developer with? Or is it more a developer that needs... Because sometimes the developer doesn't look or see production. And production... In production... This is only a thing you can test in production. It sounds weird, but this is only you can see in production, or you need to replicate the production load on your testing platform.
Yeah, you can have a post-production side.
No, but you need production load to see
to reach to that point where you can reproduce.
Yes.
To tweak the garbage collection for your container. And that's a problem, because I don't know that many companies that can
Accurately predict somewhere the
no or replay or do a load test on the real production load.
I guess like it's a very good point that you mentioned, and this was one of the learning also that I called out in the presentation. It's about having those monitors and alerts in place. Like in one of our surveys, how we identified the problem is when we had metrics around the garbage collection cycles, and that's what led to actual this conclusion that see it's not even running frequently. Since it's not running, then how it will reclaim the memory? So I guess that's where the DevOps can chime in, at least have those monitors and alerts in set up with the team. So in case, even if the team overlooks it in the beginning, but by the time they reach to that level, let's say where those requirements coming in or the service now is in the critical path, at least those alerts will immediately notify that that's not going in the right direction. And then before you reach to that day where you receive these OMs, you could already start to think, okay, what sort of actions we can take. So I guess their DevOps.
And sometimes a container can or in Java application can be too busy with garbage collection.
Exactly.
I've seen that in the past that you're getting garbage collection, and if you use the wrong garbage collection, the container will halt, do a garbage collection, will open for a few seconds, and then halt again, and then do a garbage collection,
right.
and then your service is not responding optimally, but you've got a lot of memory in that container, and then you could have situations that you have too much memory in your Java application, that it's smarter to reduce the memory, to have less memory for your Java application, then it runs faster, because the garbage collection,
He's getting there, getting there.
the garbage collection is not running that often.
Exactly.
So
Right.
the
Okay.
application is running faster because the garbage collection is not running that
Not
often
running
with less memory. And that's a thing. It's not always good to add memory. And sometimes it's better to reduce the memory because the garbage collection doesn't take that long.
Right.
Exactly.
So there is a sweet spot.
Yeah, and that's a difficult one. That's why I'm passionate about that. You heard that? Because I've seen it a lot that you need to really look at your application to get that sweet spot. And I think it's responsibility for the developer with the DevOps guys or for to do
100%.
that together. And because it's really difficult. You need production workload and you need to tweak that.
And especially in like cases like where organizations, let's say, have dedicated DevOps, dedicated SRE teams, and where the developers, like their responsibility is to just merge to master and then forget about things. I guess that's where like it's really needed that for the DevOps and the SRE teams to basically ensure that such monitors, such alerts are in place, and when things go wrong, the heap dump and everything is captured properly so that the devs can then investigate how their application is behaving under certain use cases. So yeah, definitely like I guess it's something that the DevOps and SRE can help, and GetYourGuide also, by the way. Now from these learnings we have now around Kubernetes or pods have default monitoring alerts, which is part of our service template. So any service that's now developed will by default have these alerts in place. So in case they face similar challenges that we faced in other services, then the service owners will immediately be alerted that that your garbage collection is not optimal. Maybe it's something that you need to look into.
And what kind of software do you use to measure the garbage collection? And do you use any type of software in specific?
Yes. So I didn't want to mention it in the presentation because I don't want to just market any product there, but like we heavily use Datadog profiling, and that's really helped us, by the way. Like in case of one of the service, what we did, like we rolled out G1GC, we captured all the heap, and then the next day we launched it with ZGC, and then in Datadog profiling, side by side, you can compare like how one GC performing comparing to the other. So there where you can easily like real time see how the heap was behaving under this garbage collection, and now how the heap is behaving under this garbage collector. So that tool was like super awesome. Like all the other tools that are there, they can collect the heap dump for you, but then from there you more or less dive in. But I guess the Datadog profiling for us like was really nice, like already like identifying those spots. Okay, that these are the key differences, and this is where this garbage collector is working better than the other one. So
And don't you use any other software like New Relic or Datadog or because they can also see when a heap dump or not a heap dump and garbage collects occurs.
yeah, so that's what I mentioned. The Datadog is the one that we use.
Oh, sorry.
Ah,
Yeah.
So even like the alert that I mentioned, the GC cycles, that's also on Datadog as well. So it also notified us that that your GC cycles is either running very frequently or not running at all, basically. So yeah, that Datadog is something that we heavily use.
Cool.
And I can highly recommend if for anyone under similar situations can use that tool.
Cool.
New Relic is something that I haven't used myself, so I cannot say much about it.
No, of course not.
Datadog is the one that we heavily use for that. Yeah.
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 Yeah, I'm
You're out.
I'm fulfilled.
No, you fulfilled? He's done.
I think I'm
Well, we always have a last question.
Yeah.
And if I will put a crystal ball here on the table, and as we are the Kubernetes podcast, we always ask, well, how do you see the future, or how would you like to see the future of Kubernetes evolve?
To be honest, when I first interacted with Kubernetes, sometime back in 2019, 2018, I would say, it felt like super complicated product. And then from there, things have really simplified. And right now, I guess it has reached that sweet spot where the devs feel comfortable working with, even going into further investigate things. So I guess now it's not the case anymore that a developer cannot basically go and see what's going on in Kubernetes, and which is I guess a great win compared to how things were back then. And in terms of future, I see it's definitely going to the next level from here. Things are definitely evolving, and I guess what we need is now more user-friendly stuff around Kubernetes so that we feel more comfortable working with it. And we just need to somehow bridge this gap between the dev and between the DevOps, between the SRE when it comes to Kubernetes, because when we currently talk about Kubernetes, the first thing that comes to our mind is, okay, DevOps, maybe SRE, but the thing that does not come to our mind is developers, backend engineers. But if you ultimately see it's their code that's actually getting deployed and running there, right? So I guess that's where I would like to see more, things coming in to bridge this gap and bring this side of the world, the backend engineers, more closer to Kubernetes.
Cool.
Cool.
Cool. Yeah, I would like that.
Yeah.
More
Fully
developments.
More
Yeah.
development.
Well, Usama, thank you very much for joining us in our podcast. And
Thank you for
we'd love
having
to
me.
follow up this one in the future.
Yeah,
Cool.
thank you very much.
Thank you.